Okay, welcome for our science lesson today. We are going to move on the plate tectonics. And plate tectonics is a study of how forces affect the movement of the rigid blocks of the earth. I will preview the previous lesson shortly. For us to be able to move into details of this lesson, we need to be able to understand, first of all, about the makeup of the structure of the earth, so that from there, we'll be able to know and move. When you understand that is about the structure of the earth, from the previous lesson, we learned that the earth is made up of three parts. That is, one, it is made up of the crust, and then two, it is made up of the mantle, that is the mantle, and then the third part is the core. Just to illustrate few things about the earth, the earth structure, the crust is made up of actually one rigid block. That is a rigid block that is also known as lithosphere. It is the outermost layer part of the earth structure. And it is on this layer I had outlined earlier that many human activities works and operate here, including the forces that works on Earth's surface. Those are endogenetic forces, the forces that works within the crustals part. And then we have the second part, the second layer of the Earth, that is called the mantle. The mantle is also made up of two. Remember, we can split the mantle into two parts. We have the upper mantle and also the lower mantle. We have the upper mantle and the lower mantle. Therefore, this is very important. Also, the core is made up of two parts. That is, we have the outer core and also the inner core. Now, having this knowledge, we'll be able to explain various reasons why we have the plate tectonics. Just shortly, I would like to outline that the mantle, when the mantle is actually drawn up, I will use Now, this is a simple structure of the structure of the Earth crust. We have been able to look at the first structure is also referred to as the lithosphere, which is also known as the crust. And then there is a small layer over which the crust rests on. It is known as the hydrosphere. The hydrosphere is the one that rests on the crustal continent. And then we have the mantle. The mantle is made up of two. We have the upper mantle and the lower mantle. We have the upper mantle, and then this is the lower mantle. Therefore, I wanted to show that there are two thin discontinuity layers that appears on the Earth structure. One, this layer is called moho, or it's also known as Mohorovičić discontinuity. And then there is a small layer that separates the core and the mantle. It is called the Gutenberg discontinuity. The Gutenberg discontinuity. That is now about it. You'll be able to find that Moho is a scientist who discovered the seismic wave that operates in between the crustal mantle, that is in the mantle, and also into the crust. Therefore, there are so many things that are resting here about the tectonic plates. In the previous lesson, we were able to look at the upper mantle is made up of rigid blocks. Is actually rigid, while the lower mantle is found in viscous form, is actually in liquid form. Whereas also the outer core, the outer core is also rigid. It's made up of the rigid blocks, while the inner core is made up of the semi-molten liquid form. That is now what we call the magma. Now we learned that one during volcanic eruption. It is the one that is the cause what we call eruption, so that eruption will occur on the Earth's surface as an explosion. Therefore, when we are able to look into the plate tectonic, this is the tectonic that we are talking about. This plate, the continental crust, is what we are referring to it as the plate. Then we'll have to move and find out what happens. When we have this information, we'll be able to apply it into the next into the lesson that we are going to explore, as we are able to have the knowledge about the structure of the Earth. Then we are going to look into the plate tectonic. There are two theories that try to explain the plate tectonics. One theory is referred to as continental drift. And then another theory is referred to as the plate tectonic. The plate tectonic theory. These two theories are very essential, and they explain about the movement of the Earth crust. That is the lithospheric movement. As we move on, we'll be able to see what happens during this. Now, let's begin with the continental drift theory. The continental drift theory. The continental drift theory, it's also referred to as the continents. The continental drift refers to the movement of the crustal rocks. This theory was advanced by Sir Alfred Wegener It was advanced by Sir Alfred Wegener. He was a scientist, a geomorphologist, and also an astronomer. He is called Alfred Wegener. He advanced this theory in the year 1912, and then he's the one who argued out about the plates, about the continental drift, explaining about the plates that are in constant motion. Anyway, plate tectonic also refers to a steady and a slow movement of the crustal rigid blocks. We have already referred to them as the crust, or you can also call them the lithosphere. In his book, what did he say? In his book about the origin of the continents. The origin of continents. In his book about the origin of continent, he stated very clearly some information. He said that once there was a large landmass, which is referred to as the supercontinent. Once there was a supercontinent, one supercontinent, which was referred to as, he called it Pangaea. Initially, there was one huge landmass, which is also referred to as supercontinent, called Pangaea. What happened to Pangaea? During the Precambrian period, Pangaea broke up into two. Before it broke into two, it was covered, it was surrounded by a huge water body mass that is called Panthalassa. This was a body of water that was surrounding Pangaea. Now, having that idea, during the Precambrian period, that's around many million years ago, Pangaea broke into two pieces. One piece was called Gondwana land. It was referred to as Gondwana land. The Gondwana land. And then the second piece was called Laurasian. The Laurasian shield. The Gondwana land was a piece that represented the northern, that moved in the northern parts, while the Laurasian shield moved in the southern parts. And then it was now surrounded by a narrow ocean that was called as Tethys. After some time, the Gondwana land further split into various smaller blocks that represents the various plates that are found on Earth, and also the Laurasian shield further also split into three main plates that we can now term them as the plates. Now, after the Gondwana splitting into two, it led to the formation of the continents. Right now, we are able to understand there are 7 continents in the world. And when the Gondwana land splitted and the Laurasian splitted, it went and formed, as it was drifting, it formed one of the continents known as North America. North America. The second continent was about this South America. South America. We can have Europe. We also have Asia is a continent. We have Africa. Africa is a continent. And then we have Australia. And then the seventh one is the New Zealand. These are the various 7 continents that he tried to foresee during in his book of the origin of continent. And he went ahead and explained most of these continents were once a large landmass. It was once joined together in the name of Pangaea. And then it was surrounded by a large water body mass that was referred to as Panthalassa. We are talking about this one. It was surrounded by a large water body mass that is known as Panthalassa. Today we refer to Oceanic Plate as an hydrosphere, a body that is full of water. And you can see how vast it is. In the world right now, it covers around 70% of the Earth's surface. This is made up of water. And then another percent is the one that makes up about the crust. 25%, although it is in millions kilometers square when we take the measurement. But it only takes about that smaller percentage. That is about the theory that was advanced by Sir Alfred Wegener in his book. Then, what have the geologists and the geomorphologists discovered about this continent of recent? After the development of various scientific techniques, try to discover, to dig out what is happening about these crusts. There is something unique about it. Eventually, if you understand about the surface of the earth, which represent the crust, it is not made up of smooth objects, but it is made up of sometimes what you call cracks. These cracks means that there is something that is splitting. There are some forces that do the splitting of these continental crusts. And those two forces are quite important. The two forces here that the scientists have come up with it, we call them the endogenetic force. The forces that moves within the earth crust, the endogenetic force, and there are two types. There is a vertical force, and the second one is a horizontal force. The second one is a horizontal force. These two forces, they originated during the plate tectonics, and they are operating within the earth crust. We shall be able to see their effect in a short while when we'll move to the next theory about the plate tectonic. But now, let's look about what he said also. He said that the continents seems to be moving away from each other, and there is a force behind this. And which force did he mention? He mentioned about convectional currents. He mentioned about the convectional current force as the force that is operating within the earth crust. The convectional current force, And when you are able to understand about the convectional current, is a circular motion of waves that is moving below the earth crust. And below the earth crust, we have the hydrosphere, the upper mantle. And we also have the lower mantle, that is below the earth crust. Therefore, this force, seemingly it originates from the lower mantle, where we have the viscous magma that is found in this part. We have magma. It is this magma that generates the convectional currents so that they are in constant motion. When they find cracks along the rigid blocks, they are able to split this crustal into various forms, as we'll be able to see. Now, because these continents are in constant motion, there are various evidence that scientists have tried to dig into and come up with them to prove that surely Alfred Wegener had an idea in his book, The Origin of Continents. What are the evidence that support the continental drift theory? That is what we should be able to look at. The evidence. What are the evidence? Scientific discovery have been backed up with various evidence. The evidence supporting continental drift theory. The continental drift. As we have been able to see, the continent now is made up of the rigid blocks, and it is somewhere floating on the earth crust. There are various evidence that are able to prove that surely there was once an existence of a large landmass that was known as Pangaea. Some of the evidence that have been postulated, we have the paleontological evidence. Number one, let us look at the paleontologists. We have people known as the paleontologists. They came up with paleontological evidences. And these are the people who study the remains of the dead animals and plants. We call them the fossils. Fossils. And what is it about the fossils? What did they discover about the fossils? The paleontologists discovered and they have found similar fossils of flora and fauna. The paleontologists, they have found what we call similar fossils of flora and fauna. They have found out the fossils of flora and fauna at matching localities, especially in the Atlantic Ocean side and also the South American coastline. This means that if these fossils are similar, then once they existed in the same form that was known as Pangaea, they might have originated there. That is what the paleontologists have suggested. Because the fossils of fauna These simply are the animals. The remains of the dead animals. Flora means about plants. The remains of the plants and animals who died long time ago. They were fossiliated. Remember, we have an idea of sedimentary rocks. After being fossiliated, they have been discovered where they are at matching localities. They are at matching localities. They are at matching localities where? In the coastline of Atlantic, in the Atlantic Ocean coastline, in the Atlantic Ocean coastline, and that's one of the South American coastline. The paleontologists are the people who are studying about the fossils of the dead animals. They have discovered, they have found similar fossils of flora and fauna at matching localities in the Atlantic Ocean. Both localities of the Atlantic Ocean. Now, when you look at the Atlantic Ocean is bordered by South America and an African plate. Now, when we say the both localities, we are looking at African plate and we are looking at the South American plate. The fossils found in South America and the ones that are found in Africa, they have similar characteristics. Having the similar characteristic, that sends an idea that when you have united South America and African plate, they might have originated in one time as one landmass that was propagated by Wegener. Let's look at the second. The second evidence talks about is geometric jigsaw feet. The geometric jigsaw feet. Now, when we try to outline the African plate, for example, this explain that the African plate in South America South American plate can fix into each other geometrically, and in the process, when they fix into each other, they will not leave any other space in a jigsaw manner. That means they might have originated in one landmass, but it is the splitting that resulted into them drifting away from each other. Therefore, when we are able to understand this, for example, when we have an idea of that is South America, let me begin with South America and then bring our Africa plates. This is a sketch of Africa. It's a sketch of Africa. Let us let us look at the African plate and the South American plate. When we try to bring them closer to each other, you will find them, they are going to fix, especially this part is going to fix here, and then this part is going to fix here, and then this one will fix automatically at this place in a jigsaw fit manner, in that it will not leave any other space. When we explain this, it says that the continents bordering the Atlantic Ocean seems to fix into each other geometrically in a jigsaw fit manner. This can also be a proven evidence, because when we assume if we are bringing Africa and South America plate together, they can have some similar characteristic. This is the second evidence that we can have that has been found out. Let's look about the third evidence. The third evidence is about the coal, the presence of coal. I hope now from there we have an idea of the formation of coal, since we had covered the formation of rocks, especially sedimentary rocks. Coal is believed to have been formed above the Arctic Circle, where plants grew and were decomposed into various fossils upon being fossiliated. Therefore, this region seems to have been moved in warmer climatic conditions where plants could only grow, and upon maturity, some of them died and they were decomposed, and then in the process of being fossiliated, that they undergone a fossiliated process, and then coal is formed in this manner. When you look at where coal is found in today's world, the distribution of coal in various regions of the world, or the presence of coal in various regions of the world, it sends an idea that this might have been in regions where there was warm climate, especially within the Arctic Circle regions, where the flora and fauna were growing, and upon being fossiliated, they undergo burial, and that burial lead to the formation of coal. Therefore, the region might have been existed in one supercontinent, referring to it as Pangaea. That is an evidence number 3. What about another evidence? Scientists have various evidence to show that surely the continental drifts originated from a huge landmass. The paleomagnetic evidence. We have paleomagnetic evidence. We are focusing into the magnetic field of the world. That will bring us to the idea of magma. Many studies have revealed that during volcanic eruption that have been happening periodically, but the ancient eruption that happened upon the lava flowing, when the lava was flowing, especially on Earth's surface, the mineral content that are found in the inner core, such as iron, are found to align the Earth structure, or the Earth as a block now, as a plate, to align itself into the northern poles and the southern pole's magnetic field of the earth. Therefore, when you have a magnet, for example, and throw it up, it will always come and align itself. You know, the idea of South Pole and North Pole will have to attract each other, and North Pole and South Pole will have to attract each other. The materials or the minerals, especially ions, have been found aligning themselves to the magnetic field of both North Pole and South Pole. This is what we refer to as paleomagnetic evidence, and it has been proven that even when there is a volcanic eruption, when magma will have to extrude itself into the crust or rocks, when it cools and solidifies, the mineral content such as iron and nickel, they are finding themselves aligning themselves to the magnetic field of the earth. Remember, the earth as a structure is made up of two poles, the northern poles and southern poles. That gives us an evidence that surely once there was a huge landmass that was known as Pangaea. And it is from this that it splitted into various blocks that resulted into the formation of other blocks, other rigid blocks that we are able to see. Let's look about another evidence. This one is about the glaciation. In ancient period, we have been able to see the crust resting on hydrosphere or oceanic plate at a given time during the formation of the glaciers. During the formation of glaciers, we cover this part in weathering, especially the mountain across different continents. They have been found matching in their structural edge and the rock composition. This suggests that those mountains were once formed in a series of ranges where it happened in one huge landmass that was a supercontinent. They suggest that. And actually, when you look at the composition of the edge of the glaciers and the edge of the rocks, you will be able to find them being formed almost the same geological age, which can be traced during the glaciation period. In the formation of glaciers, remember, we are talking about some form of weathering that happened during that time. It resulted into some debris of rock fragments that to have similar age and composition might have originated in the same place. That's why when you took the edge of that rock, the geological edge, when you look at the mineral composition and the edge, these mountain ranges have the similar characteristic. That means they might have been formed in one particular region during the Pangaea period. The last one that we will look at as an evidence is about the Red Sea. The current Red Sea in the world. When you have a global map or an atlas, try to locate the Red Sea. You'll be able to find that the Red Sea borders some two continents, that is the African continent, and on the opposite side, the Saudi Arabian. The Red Sea evidence shows that the underground are lateral displacement in the flow of the Red Sea. The underground lateral displacement in the flow of the Red Sea have had similar characteristics like that one of the formation of coal. This might give us a proof that this plate, the African plate and the Saudi Arabian plate, are slightly moving apart. They are drifting from each other, but they might have originated from one particular region, that is referring to the Wegener's proposal of one huge landmass that was referred to as the Pangea. Those are some few evidences that scientists have come up with to show that surely Sir Alfred Wegener had something to tell the whole world. And as a result of that, when he summarized the whole of his point, he said that these continents seemingly to be moving away from each other in a drifting manner. Although we may not be able to discover, but geological statistics are showing that there is some lateral displacement that is happening over the tectonic plates. That is one theory with its evidence about Sir Alfred Wegener, who advanced the theory of continental drift. Shortly, let us look about another theory that talks about also the plate tectonics. This theory is referred to as plate tectonic. Just as I've written, it's referred to as plate tectonic theory. And a theory is an idea of facts that try to explain the origin of a given ideas that have been put across. After now understanding the whole structure of the earth, we are able now to have a knowledge that the earth is made up of three structures. That is the crust, the mantle, and the core. But we are basing on the continental crust. That is the first one. We are now looking into the continental crust. We are still studying about the first block, and we are looking into it. After understanding about the continental crust, it is made up of the rigid block. These blocks are called plates. We are able to learn that the earth, or the structure of the earth, is made up of rigid blocks. These rigid blocks are called plates. We just call them plates. And plate tectonic is a theory that tries to explain the movement, the steady movement of this plate. Why are they moving? And why are they, when they move, there are some effects on earth surface, such as we can be able to see earthquakes, can able to experience volcanicity and other tremors around some regions of the world. There is a theory that states this, and this is referred to as the plate tectonic. It is almost have some similar characteristics like Sir Alfred Wegener's, but this one states that the structure of the earth crust may have been associated with the phenomena that is resulting to the formation of interaction of the rigid lithospheric blocks that are in constant motion in the underlying mantle. Therefore, now this one depicts the idea of the interaction between the continental crust and the mantle. This one states that the Earth's outermost layer, that is the lithosphere, broke up into just immediately 7 large rigid blocks that are called plates. The Earth crust broke into 7 broken rigid blocks. These rigid blocks, the state they are called plates. These pieces have 7 main blocks, and they just begin by explaining one of the blocks include Africa. We have Africa, we have Asia, we have Eurasian Plate, we have the Eurasian Plate. You can remember other plate, Australian Plate. And then we have Antarctic Plate. The Antarctic Plate. We have the Pacific Plate and North America. We have the Pacific Plate. And also we have the North American Plate. But the idea plate tectonic is trying to mean they are trying to build on what we call Pangea. This one, as a rigid block, it broke into 7 pieces of rigid blocks that are known as plates. And these plates are equivalent to Africa, Asia, Eurasian Plate, Australian Plate, Antarctic Plate, Pacific Plate, and North American Plate. And there are other smaller or the minor plates that they are trying to be formulated around these 7 huge plates. And this one include, we have some minor plates. We will not fail to mention them. There are some minor plates that were also formed alongside this, and this plate include the Arabian Plate. We have the Nazcan Plate. These are very minor. We have the Philippine Plate. We also have another plate that is called Cocos Plate. The Caribbean Plate. We have another plate that is known as Juma diffuca. And lastly, we have the Somali Plate. These are other several minor plates that are formed alongside the 7 known plates that we know. These plates, they are in constant motion. This is what tectonic plate speaks about. They are in constant motion and they are moving in all direction in approximate of around 2 to 10 centimeters apart, that is per year or per annum. That means they are moving at the rate and the speed of the growing of your fingernails. If you leave your nails for over 12 months, you will detect some centimeters, about 2 to 10 centimeters long. That means that is the rate at which these plates are moving away from each other. And as a result of moving either away from each other, what will be the results of moving away or moving in all direction? Now, this gives us an idea that you can remember a vehicle that is in a car derby. What happens? This vehicle can be moved in every direction. And as it moves in every direction, it may crash or bump into each other. And as a result, there are some impacts will be affected. The same way, we can have the same idea of these 7 blocks as they are moving constantly away from each other. Some are moving closer to each other. They are resulting into either pulling away, they are pulling away from each other, creating some boundaries. And even as they bump into each other, they side sweep or they side swipe into each other. We can also use another word, they shear. They also create some boundaries. For example, let's imagine of this plate. This is a plate that is moving, and another plate that is moving. Either they can move towards each other or they can move away from each other. What will happen, because this is a stream of water, remember it is still on the oceanic plate. When this plate is trying to move closer to each other, this surface and this surface will meet and side sweep or shear, or they may also cause what we call tearing each other. And as a result of that, there are some boundaries will be created. These boundaries will be able to discover them along the way. And this we are able to find out as a result also of their movement. As a result of their movement, of the plates. We need to be able to understand that there are 2 plates, 2 types of plates. And this one, we have the oceanic plate. Now we'll have to bring an idea of an oceanic plate. And then also the continental plate. There are actually 2 plates that are trying to play around each other. The oceanic plate, that is a plate that is composed of large water body mass, I had stated earlier, but the continental plate is the one that we are discussing about it. After it being split into 7 large continents, what is happening? There are some movement associated to it, and as a result of those movements, we are going to see the effects that will be happening around this plate tectonic. Having been able to look at both plate tectonic and the continental drift, we are able to understand now the origin of the continents according to a scientist who first postulated it around 1912. And we are able to understand what happened around this large body. I want to leave us with this question for us to be able to ponder about it. Name the supercontinent. Name the supercontinent that was discovered by Alfred Wegener. And identify two features that were surrounding it. This is a question for you to explore so that for us to be able to understand about this aspect. Which is this continent that is discovered by Alfred Wegener? Simply, Alfred Wegener discovered one supercontinent that was referred to as Pangaea. And then we have to identify two other parts that were surrounding it. And one, it was surrounded by a large water body mass that was known as Panthalassa. And then, upon splitting it into two, it formed what we call the Gondwana land and Laurentian shield. These were the two major parts that were surrounding the Pangaea aspect of theory as it is outlined by Sir Alfred Wegener. Having looked at this, then we are able to understand. In the next lesson, we'll be able to look at various effects of this continent. Have a good day. Thank you.